Hello everyone, welcome to all of you in my YouTube channel Chemistry by Saad, and my WhatsApp number is given here. This is lesson number 14, and previously I have uploaded 13 lessons about GCSE chemistry, IGCSE chemistry, and very basic chemistry. So you can contact me for tutoring because I am providing my tutoring services across the globe. And today what we have to discuss, what we want to discuss, the today topic of discussion is how to write ionic equation. In this topic, we will learn how to write ionic equation and what ionic equation is. Ionic equation, as the name is indicating, ionic equation is that equation in which there are ions, there are positive ions, there are negative ions. The equations which have positive ions, which have a negative ion, this equation is ionic equations. I am taking an example of a chemical reaction in which sodium hydroxide is reacting with copper sulfate, and the product which I am getting is copper hydroxide and copper 2 hydroxide. So I have to put 2 here, and sodium sulfate. Na2SO4 is the formula of sodium sulfate. Now the point is, first of all, I have to mention the states. Means I have to mention this reactant is in aqueous form, this reactant is in solid form, this reactant is in liquid form. Similarly, I have to mention my product is in solid form, or my product is in liquid form, or my product is in gaseous state. I have to mention the state, and for that I have to use state symbol. And I now sodium hydroxide is soluble in water, so I will put AQ. Its state is aqueous state. And copper sulfate is also soluble in water, so I mention AQ here, aqueous state. And sodium sulfate is again soluble in water, so I mention AQ here. But copper hydroxide is not soluble in water. So it means copper hydroxide remain in the form of precipitate, means remain in the form of solid state. And who is telling me that sodium hydroxide is soluble, copper hydroxide is soluble in water, sodium sulfate is soluble in water, but copper hydroxide does not soluble in water? Who is telling me? My previous knowledge. And I have uploaded a video. I will share the link of that video in the description box. And I suggest you guys first watch that video. The topic of that video is, the title of that video is solubility of salt. I have uploaded the video, and the topic of that video is solubility of salt. If you watch solubility of salt first, then you will be able to understand this video fully. And just for a quick revision, let me show you one thing. This is a table here, and this table is explaining about something about solubility of salt. Remember, guys, this is, in this column we will put those salts which are soluble, and in that column we will put those salt that are insoluble. All common sodium, potassium, and ammonium salts are soluble. I have uploaded a separate video as well, and I suggest you guys to watch that video first. All nitrate salts are soluble, most chloride salts are soluble. Remember, silver chloride insoluble in water, lead chloride insoluble in water. Means if you have silver chloride and if you have lead chloride, then these salts remain solid. Most sulfates are soluble in water except lead sulfate, barium sulfate, calcium sulfate. But sodium, potassium, ammonium carbonates, they are insoluble. They are soluble in water. And rest of the carbonates, they are insoluble in water. This is the important point here. This is the important point here. Sodium, potassium, and ammonium hydroxide, they are soluble, and all other hydroxide are insoluble. If we have copper hydroxide, remember, sodium, potassium, and ammonium hydroxide are soluble in water. But if we have copper hydroxide, they are insoluble in water. Copper hydroxide are insoluble in water, so we have to put small s, means copper hydroxide remain in solid form. Now I am going to open whiteboard. Okay, fine. So sodium hydroxide is soluble. Okay, I have mentioned their states as well. From sodium hydroxide, I will get sodium ions in the form of in the aqueous form. Then I will get hydroxide ions. Then I will get hydroxide ions. Oh, one another thing. I have to balance this equation first, and I will put 2 here to make this equation balanced. Now this is balanced equation. So I have 2 sodium ions, and similarly I have 2 hydroxide ions here in the form of aqueous. Means sodium hydroxide is giving me sodium ion and 2 hydroxide ion. Similarly, calcium sulfate is giving me calcium ion aqueous, and sulfate ion aqueous. I am getting, sorry, this is copper ion. I am getting copper ion and sulfate ion from copper hydroxide. Guys, remember copper hydroxide. They are solid. They are solid. It means it will not dissolve. It will not convert it into ions. No ions. I am getting no ions here. Very important point. I am getting no ions here because copper hydroxide is soluble, and I know most hydroxide are insoluble in water. Copper hydroxide is insoluble in water. Copper hydroxide remain as precipitate, so I will get no ions from copper hydroxide. But from sodium sulfate, I am going to get sodium ions in aqueous form, and I am going to get sulfate ions in aqueous forms. Guys, there is something new and something very important going to, like you can see sodium ion is there, sodium ion is there. You can see sulfate ion is there and sulfate ion is there. We call such ions which are present at reactant side as well as present at product side. We call such ions spectator ions. First of all, let me write what spectator ion is. Spectator ions. Spectator ions are those ions which remain unchanged, which are present at product side, which are present at reactant side. Spectator ions are those which are present at product side and which are present at reactant side. So let me write the definition of spectator ions here. So this is the definition of spectator ion. We can see sodium ions and sulfate ions are common to both sides of equation. You can see here, guys, sodium ions and sulfate ions, they are at both sides of the equation. They are called spectator ions, and the rule is we can cancel these ions. Like I can cancel this sodium ion with that sodium ions, and I can cancel sulfate ion with that sulfate ion. So the ions, the ions which left behind are from here copper ion, and I need to write positive ion first. So copper ion in aqueous, copper ion in aqueous. Then the ions left behind is 2 hydroxide ions, aqueous, and I am getting here no copper hydroxide in the form of precipitate, in the form of solid state. This is my ionic equation. This is, guys, this is the concept. This is all about ionic equation. Ionic equation is that equations in which we have ions. So now let me take another example of ionic equation. Let me take another example of ionic equation, guys, and you can take a screenshot of these pages as well if you want. So there is an equation, guys. Let me write that equation first to save your time. So guys, welcome back. This is lead nitrate. PbNO3 whole twice is the formula of lead nitrate. And this is sodium chloride, the very famous formula NaCl. And this is lead chloride, PbCl2 is its formula, and sodium nitrate, NaNO3 is the formula of sodium nitrate. Now, first, an important thing which I have to mention here is the states. Lead nitrate is aqueous state. Remember, sodium chloride is also aqueous state. Lead chloride, this is solid state, means Lead chloride is not soluble in water. Who is telling me my previous knowledge? Like again, I suggest you guys do watch my lecture about solubility of salt. Then you will be able to figure out which salt is soluble in water and which salt is not soluble in water. Then you will be able to then you will be able to mention the correct state, aqueous state or whether solid state here. This is again aqueous state. And the simple thing is, you don't need to write, when you have to write ionic equation, you don't need to mention aqueous states. Oh, sorry, I want to say, when you need to write ionic equation, just forget those salts which are in aqueous states. Listen my words attentively. When you need to write ionic equation, ignore those salts which are in aqueous states. Just pick that salt which are in solid form. Like I am ignoring lead nitrate because they are in aqueous state. I am ignoring, this is a trick. This is a trick. I am going to explain a trick with you. The NaCl is in aqueous state, so I am ignoring it. Lead nitrate, sodium nitrate is in aqueous state, so I am ignoring it. Lead chloride is in solid state, so I am going to pick it. And from this I will get lead ion. This is a trick. Put aqueous here. Then I am getting a chloride ion. This is a trick to write ionic equation in a very short time. And what is the procedure? Procedure is pretty much simple, that from here I will get lead ions in aqueous form, and I will get nitrate ion again in aqueous form, and from sodium chloride I will get sodium ions in aqueous form, and I am going to get chloride ions in aqueous form. These ions I am going to get from the reactant, and product no ions because this is in solid forms. Sodium nitrate, I will get sodium ions in aqueous, then I will get nitrate ions, and then I will get a nitrate ions. One thing mistakenly, I need to balance this equation first of all here. Put 2 here. When you put 2 here, you will get 2 sodium ion, 2 chloride ion. 2 sodium ion here, and similarly 2 nitrate ion. Means you have to balance this equation first. Now these are spectator ions. Nitrate ion can be cancelled. That nitrate ion, that sodium ion can be cancelled with that sodium ion, and the ions left behind are lead ions in the aqueous state, and the other is 2 chloride ions in aqueous states. And when lead ion combined with 2 chloride ion, you will get lead chloride. Don't forget to mention this is in solid state. So this is the way how to write ionic equation. And previously I have shared a trick with you guys as well. So I need your feedback comment as well. Your feedback comments are very important for me. Do share your feedback comment with me. Thank you so much for watching.